calculus is hard. But it can also be fun at times. In this video, I will be going over the limits and summations, aka the boring part. Many people may argue in the comments saying,
the summations on calculus, this stupid.
Listen, if limits are going to be considered calculus, then I think summations should be as well.
Understand?
Now, the idea of the limit is to approach any number on a function without actually getting to that point. Okay, you're probably wondering, what the f does that even mean? Well, suppose we took the limit of x squared as x approaches 2. The answer would be that the limit is approaching 4. Get it? We're not actually getting to the number 4, we're just simply approaching it.
Isn't that exciting?
Imagine the closest number to 4 without actually getting to 4. Now take that number and make it 1,000,000 times smaller so you can no longer fathom how small the distance is between those 2 points. That's just how close we are to the number when taking the limit. You can think of this distance being infinitely small, or infinitesimal, meaning it's so small you can't even measure it. I recommend you don't think about it too hard, or you'll wind up in a hospital. Okay, so besides the whole infinitesimal thing, the limit's pretty easy to understand, right? You're just plugging the number into the variable of the function. How hard can it be? Well, it's not always that easy sometimes. For now, I'm just going over the basics of limits. Since math is all about practice, here are a few limit problems for you to try out. If you get stuck on any of them, I recommend using Symbolab. It's easy to use, and it shows how to do the problem for free. This isn't an ad, I'm just showing my love and appreciation for Symbolab. Once you've understood the basics of limits, it's time to move on to summations. Summations will make anyone look like a genius. A 4th grader can do a summation. That's just how easy summations are. Well, sometimes. But I'm not going to talk about those kinds of summations yet. Okay, so let's talk about the notation. What does all this shit mean? Well, we can think of it as a for loop, if you know what that is. The x is where you start, and the number on top is where you end. And you just keep adding the loops together until you reach the end of the summation. So this summation would equal 12, because we're adding 4 3 times.
I'm so fucking smart!
Well, not exactly. That was just an appetizer. Here comes the main course. Now, this problem is a bit more challenging, but nothing you guys can't handle. Basically, you're just adding all the functions together with the value of x incrementing by 1 until you get 4. Remember, x is where the number begins.
This is crucial to remember. Do not forget this.
After that, you'll get something that looks like this, and to get 90. It's really not that hard. I hope my explanation was above tolerable. Here are a few problems for you guys to solve. If you get stuck on any of them, please use Symbolab.
I will not help you in the comments.
The next part of this series will be on derivatives. That's right, real calculus.